Section 2.3 is on linear functions and slope-intercept form. The slope of a non-vertical line is the ratio of the vertical change to the horizontal change between 2 points. It can be calculated as follows. The slope, or the letter we use is m, is the vertical change or the rise divided by the horizontal change or the run. And the formula we can use is y2 minus y1 over x2 minus x1, where your ordered pairs are x1, y1, and x2, y2. So let's do a couple examples here. So it says find the slope of the line through each pair of points. Let me leave that formula there. So number one, we have negative 10 and 2 and 4 and negative 5. If it helps you to label them, x1, y1, x2, y2, indeed do that. And in fact, it doesn't really matter which ordered pair is x1, y1 and which one's x2, y2. Just keep your 1's together and your 2's together. So the slope is going to be y2, which is negative 5, minus y1, minus 2, over 4 minus a negative 10. That's going to give me negative 7 over 14, or simplified is a negative 1/2. My second example here, let me bring this down a little bit more. Okay, I'm going to do my slope is equal to negative 1 minus a negative 1. Be careful with your negatives. Make sure it is actually a negative 1 minus a negative 1 over 5 minus 6, and also make sure that you're subtracting in the same order. This is going to give me 0 over negative 1, and 0 on the top means that that is actually equal to 0. Let me go ahead and box my answers here. Okay, and our third example here, the slope is going to be negative 3 minus 5, that's y2 minus y1, over negative 2 minus a negative 2, which gives me negative 8 over 0. And remember, you cannot divide by 0, so the slope of this line, we say that this is undefined. And I want you to use that word when you're describing the slope of this kind of line when you get a 0 on the bottom. Here's a little table from your textbook that kind of goes over what this looks like. So if a line has a positive slope, then the line rises as it goes from left to right. So as we read from left to right, the line is going up. A line that has a negative slope is going down as we move from left to right. A horizontal line has a slope of 0, so that's actually m equals 0. That is a number. And a vertical line is one that has an undefined slope, and I want you to use that word undefined. Okay? A linear function is a function whose graph is a line. The function can be represented with a linear equation whose solution is all of the ordered pairs that make that equation true. One way to write a linear equation is in slope-intercept form, and that's y equals mx plus b, where m is the slope and the point 0b is the y-intercept. Intercepts are the points, where a graph crosses the axis. The x-intercept is the point where a non-horizontal line crosses the x-axis, or that would be right here. And the y-intercept is the point where a non-vertical line crosses the y-axis, and that would be right here. So let's take a look at a couple examples here. It says write an equation for each line. In this line, the slope is negative 3 and the y-intercept is 0, 5. So that means m equals negative 3, b equals 5. So I want to just plug those into y equals mx plus b. And remember, in a linear equation, x and y stay x and y. So y equals negative 3, because that's my slope, times x plus 5. And in fact, I can even kind of go backwards and look at that equation and say, I know that the slope is negative 3, and I know that the y-intercept is 5. Let's take a look at this graph for number 2. So it doesn't tell us what m and b are, but we can figure that out. This point right here is my y-intercept, and so that means that my b is equal to negative 1. And now to find my slope, I'm just going to count. So how much do I go up and down, and how much do I go left and right as I move from one point to the other? So here I'm going to go up 2 and right 3. So up 2 and right 3. Remember, it's the change in the y over the change in the x, and that represents a slope of, put the m over here, a slope of 2/3. I could also look at this as if I wanted to go from this point to this point, I could also be going down 2 and left 3. Whoops, sorry about that. Which would be, so if I did down 2 and left 3, that would be a -2 over a -3, which a negative divided by a negative is a positive, so it's also 2/3. So the equation of this line is y equals m, which is 2/3, times x plus b, which is a -1. Okay, here's a couple more examples. This says write each equation in slope-intercept form, then identify the slope and the y-intercept. So what we're looking to do is to write this in y equals mx plus b, which basically means we're going to be solving for the variable y, and we're going to make sure that our term with the x comes before the constant term that doesn't have an x. So here we have 2x plus 3y minus 15 equals 0. So the first thing I want to do is get 3y by itself. So I will subtract 2x on each side, and I will add 15 on each side. And now dividing each by 3, I get y equals a -2/3 x plus 5. That's my equation in slope-intercept form. My slope is -2/3, and my y-intercept is 5. Second equation is 12 equals 10y minus 3x. So I want to isolate my y, so I'll move the 3x to the other side. So adding 3x to both sides. And I would really like to have my y on the other side, so I'm just going to flip this whole thing around the equal sign. Let me move this up a little bit here. So I'm going to write this as 10y equals 3x plus 12. Okay, and now dividing everything by 10, I'm going to get y equals 3/10 x plus 6 over 5. And most of the time when we're writing, well, almost all the time, we do leave the slope as a fraction, and it's okay to leave the y-intercept as a fraction as well. And in fact, as an improper fraction, I think that's what I tend to see most of the time. If I were actually going to graph this using the y-intercept, I would turn this into a mixed number so I would know what it looks like. So my slope is 3/10, and my y-intercept is 6/5. And now let's take a look at an example where we have to graph an equation. So here I have the equation 24 equals 4x minus 3y. And in order to do that, I want to rewrite it in slope-intercept form. I think I'm going to start this one by flipping it around the equal sign. Okay, now let's solve for y. Let's subtract 4x on both sides. Remember, keep that term that has the x in front, in front of the term that doesn't have an x. Okay, and divide everything by -3. So that gives me y equals 4/3 x minus 8. So my y-intercept is -8, and I like to think of that in terms of, since my y-intercept is designated by the letter b, that's where I'm going to begin my graph. So I'm going to start with -8 on the y-axis, which is this point right here. So that's my beginning point. Now my slope, my m, is 4/3, and that's going to tell me how I'm going to move from my y-intercept. So a +4 means up 4, and a +3 on the bottom means right 3. Now, I could also write this as -4 over -3, because a negative divided by a negative is a positive, and a -4 on top means down 4, and a -3 on the bottom means, whoops, let me redo that, means left 3. And I don't know that I have room on this graph, but I'll show you what that looks like. So from my beginning point, my y-intercept, I'm going to go up 4, and I'm going to go right 3 and put a dot. And I can keep doing that. Up 4 and right 3, up 4 and right 3. Okay, or if my y-intercept is kind of low on my graph, but I could also go down 4 and left 3, and that would give me a point somewhere down there, and that's also going to be on the line. And then connect those dots and put arrows on the end. So in this section, we took a look at linear functions and especially how to write a linear function in slope-intercept form. We went over what slope is, what our x and y intercepts are, and particularly the y-intercept, how to write an equation in slope-intercept form, and how to graph the equation once it's written in slope-intercept form.